LiveAction is a full Cisco ecosystem partner. We are well known for our deep integration with Cisco DNA Center, SD Access, and Viptela SD-WAN. In this video, we will be focusing on LiveNX's integration with Cisco SD-WAN. Today, I'm going to show you the power of visual analytics in visualizing your Cisco Viptela SD-WAN, and I'm going to demonstrate the following use cases listed on screen. One of our users even noted that their NOC team were able to resolve 90% of their network issues through using LiveNX's visual analytics. With that being said, let's dive in. This is LiveNX's GeoTopology View. We can visualize the application traffic flow in Cisco SD-WAN networks. As you can see, the dotted line is the SD-WAN VPN tunnel. The red dots in the GeoMap represent the sites. The colored lines represent different applications in the network. Many SD-WAN users, especially big customers, segregate their network by using VRF or VPN per business unit. One way you can track VRF is by changing the display option here. And now the GeoTopology view is showing VRF in the network. In this demo system, we can only configure one VRF. But if you have a few VRF in your network, you will see multiple colors. Another way would be to take advantage of our filter functions by choosing VRF10. If you switch the display back to WAN applications, you will see the types of applications permitted in the VRF network. For our second use case, you can use the GeoMap to track application traffic through your network. You can visualize the application path by selecting the application name from the below legend. Here you can see VoIP, RTP traffic, Netflix, and so forth. And from a glance, you're able to understand which path applications are taking in your network. You can even enable the internet option to see DIA traffic. Another use case is DSCP marking verification. You can filter by application name. We will do VoIP. By switching the display to DSCP, you will see the DSCP marking. With this topology map, we can quickly confirm the VoIP traffic is marked correctly with EF46. The next use case is application route verification. If you want to know which route or service provider this VoIP traffic takes in your network, you just switch the display to service provider. And now you can see VoIP traffic was routed through both business, internet, and MPLS. To check the policy, click here. From this, we know that VoIP should primarily take the MPLS service provider path. But now we're seeing it took two different service provider paths. So what is happening here? This is where use case 5 comes in, which is WAN link performance verification. Click on the red dashed line between the two sites. You can see the performance per service provider of the VPN tunnel. Notice that the business internet path is green for each of the SLA classes, but the MPLS is having very high latency of 201 milliseconds, which violates the voice video SLA class threshold, explaining why the VoIP traffic takes two different paths. By clicking on this button here, it will take you to the site-to-site Sankey Diagram. This will help you to understand all the traffic going from San Jose to Chicago. We can break it up by application, then VRF, the DSCP value, along with service provider path they are taking, whilst relating this all with performance metrics coming in from vManage. The blue colored bands are showing you the amount of bandwidth for each application and the network path they are taking between the sites. Let's zoom in to monitor VoIP traffic. Notice at the point in time it's being marked as EF46 and it's taking the business internet path and MPLS. By clicking play, we can visualize the traffic movement from the business internet path back to MPLS. To further drill down, you can click on Service Provider, which brings up that service provider's detailed reports, showing information like peak jitter and peak loss rate, and much more. To try out LiveNX for yourself, please visit the website on screen. Thank you!